Hi and welcome. I'm trying to learn biology, today proteins. And after we've done that, we're going to do a bit standing yoga. And if you participate in the standing yoga, that is the down risk. Proteins are needed for growth, and so it is important to eat the correct amount. Okay, proteins in the human body are for growth there, and it is important to eat the right amount. This is called the estimated average requirement EAR, and can be calculated using the formula. EAR is in gram equals 0.6 times the body mass in kilogram. But I want to add directly what is written here. The EAR is an estimate of the mass of protein needed per day based on an average person. The EAR for protein might be affected by factors such as age, pregnancy, or lactation. For example, now I haven't read the text, I just read the beginning to find the title of the video. So, protein, the estimated average requirement is really the official name. Estimated average requirement is it. That name doesn't include the naming that it is for protein, so it doesn't really make sense to use that name as an official name. The protein EAR can be very estimated, calculated with calculating 0.6 times the body mass in kilogram, when in gram comes it from. Too little protein in the diet causes a condition called kwashiorkor. This is common in developing countries due to overpopulation or a natural disaster and lack of money to improve agriculture. Too little protein in the diet causes the condition called kwashiorkor. This is common, this happens in developing countries where it is common due to if there's a lack of food, what do we want to basically due to overpopulation which affects the dietary plan, or a natural disaster if there's a natural disaster and food access is diminished, or a lack of money to improve the agriculture or to buy the food, or hundreds of other reasons. Now, the condition of having too little protein is called kwashiorkor, and there are regions in the earth where it is more common than in other regions. Okay, we're going to read a little bit on. The EAR is an estimate of a mass of protein needed per day based on an average person. The EAR for protein might be affected by factors. For example, just a little example list: the age, if a person is pregnant, or also if a person practices breastfeeding, lactation. Some amino acids can only be obtained from the diet, and they are called essential amino acids. And where we have it, that is an essential amino acids, because it has to be obtained through the diet. That is why we call it essential amino acids. That's where the word essential comes from. Some amino acids can only be obtained from the diet, and they are called essential amino acids. Although proteins cannot be stored in the body, some amino acids can be converted by the body into other amino acids. Okay, the human body cannot store proteins, but some amino acids, they have something to do with proteins, can be converted into other amino acids, which when can you store? Proteins from meat and fish are called first-class proteins. Okay, first-class proteins. Does the person eating that get directly proteins or also amino acids, and they are then converted? Proteins are, we have it here, long chains of amino acids. Proteins consist out of long chains of amino acids. So there are amino acids and they are chained one after another, like a train. Proteins from meat and fish are called first-class proteins. It is a bit important that we know here scientifically accurate if the proteins come from meat and fish or just the amino acids out of which then the proteins are built. And these first-class proteins from meat and fish, they contain all the essential amino acids that cannot be made by the body. The proteins eaten by meat and fish, or the first-class proteins, because they contain all the essential. So there are proteins which have all in, so all in one. I think that This is like a high claim, all in one. There's a protein which has all amino acids which humans need. It's a high claim. I want to actually have it a little more precise. Yes, this is what we mean. This is what it is, and not more or less in a sentence. And that leads me to the problem, because I want that I'm not taking it completely as it's every amino acids you need is in first-class proteins. Eating meat or fish gives you all the amino acids you need. Plant protein, I think that is what we're writing here. I'm not so sure if they're actually meaning what we're writing here. Plant proteins are called second-class proteins, as they do not contain all the essential amino acids. The amino acid that is in shortest supply is called the limiting amino acids. This is to restrict the growth of a person. What do they mean in shortest supply? For an average person, for a person in the developing countries, they have to be precise with the scientific thing of claiming what amino acids is the first one becoming the limiting amino acids. I think that is a made-up, invented name and not a fixed term, and it's the classification of this amino acids which is missing, no matter what amino acid that is. It is just the limiting amino acid, and that is not the name of one acid. As a little overview, it would be nice to know how many amino acids are there. And then there's my question. All these, what are they? 2, 3, 500, 10,000? I actually think it is a large number. Not like 10,000, but a large number. Are they all in first class, in one single first-class protein? What makes a protein a first-class protein? To come from meat and fish? Or that it has all the other one in it? How can there be one protein having all amino acids in it? Are there really not amino acids which some people have need of, which are not... If there are many amino acids, there are certainly some people who need certain types of amino acids. We're having here the EAR changes, the mass of protein, or is it that just protein work for everything? How many types of amino acids are there? Are they all in one protein, no matter what protein, as long as it is a first-class protein? Do all proteins work? It's like all eggs in one basket. I really don't know more questions I have. I'm not really seeing that as a bad sign. The amino acids that is in shortest supply is called the limiting amino acid. This will restrict the growth of a person to the mean the height. What about people who have already reached the height? Because growth is also growth and repair are proteins used for. There are different types of amino acids. And how could it be that the one who is the first one missing is the one affecting the growth? If it's just a random one missing, it would make sense if different amino acids have different functions in the human body. Now, why should directly the first one missing the one affecting the growth? Or is it the growth of the cells that will mean that? And that no matter what repair, no matter what cell, no matter what type of organ, no matter what differences in the humans are, they are affected. It is always the phase of a cell repair which is the growth of a cell repair. No, if a cell is, no matter what cell, no matter where in the human body, no matter the brain or another organ, if a cell is made new, repaired, grows or whatever, it is the stadium of a cell which is growth, which is always affected, no matter where what cell is. I think it's a good sign that we're having more questions than we read. Let's just read the last end on. We have to do it. If you eat too much fat and carbohydrate, they are stored in the body. Carbohydrates are stored in the liver as glycogen or are converted into fats. There is a limit to how much glycogen the liver can store, but fat storage is not so limited. Fats are stored under the skin and around organs as adipose tissue. Although proteins are essential for growth and repair, they cannot be stored in the body. Yeah, we read it to the end as we wanted. Okay, we're going to go to the next part, and when we go to examine the closer, we will take in the future way more scientific accurate, not scientific accurate, yes, also scientific accurate, and I mean that in the sense of they don't intend to be that scientifically specified as I'm interpreting it. We will take other material But we will continue with the material we have. Here's a lot written. We need it as a foundation to go to the other parts. What I want to say is, this is scientific accurate. We just want to have it precise, more precise. Now, that was for this part, proteins. We will continue the next part with resource material to proteins. If you're here for biology, proteins, you can go directly to the next video. We will continue also. We will do now the standing yoga. If you participate in the standing yoga, that is at your own risk. We're doing the feet standing together and we're doing the eagle to wings in a shorter time. And out the arms down. So I'm doing speed yoga or power yoga. And out the arms down. And we're working a lot with the breathing. And out the arms down. Again, in the arms up. And out, open them to the side for police officer. Again, in. And out to the other side. Again, in. Open the feet a little bit, an inch, and out to one side. We're doing the hide and seek playing palm tree. Again, in and up. And out, we're sinking down into half. Chair. Again, in and up. And open to one side. Again, in and up. And out and down. Again, in and up. And something similar. Open the arms to the side. Again, in. And out. We're going down. Arms on the side, down, down into full chair. The breathing in, coming halfway up. High up and out. Again, in. And out, open to the other side. Again, in. And out, open to the other. Again, good on. And in the full chair, breathe in, come up, yeah. High up and out and up. No, we're not fasting, we are doing power yoga basically. And now we are breathing in and reaching high up, coming up onto tiptoes. And out, we're sinking down. Again, in and up. And out and down. And another time, breathe in and up. And out and down. Now breathe in, come up. And breathe out, we're doing the down diving dog from the arms over the sides down, the feet together, breathing out and coming down. Now we're doing the marmot. Breathe in, bend the right knee. And breathe out and stretch the left leg. Again, in and change. And out and stretch the right leg. Again, in and change. And out and stretch the left leg. Again, in and change. And out and stretch the right leg. Again, in, both legs straight. Breathe out, both legs straight, just down. We're doing the penguin. Breathe in, lift the right hand up to the sky. Breathe out, bend the left knee, look over the right shoulder to the right hand. Breathe again in, bring the arm in. And out and down. Breathe in, lift the left hand up to the sky. Breathe out, bend the right knee, look over the left shoulder to the left hand. Breathe again in, the hand in. And out and down, both legs straight. We're doing the pelican. Make a hand with space between the feet, shift the weight to the heels, and breathe in and go down. And out and up. Again, in and down. And out and up. And the last time in and down. And out and up. Take hold on the elbows. We're doing the chair machines counterweight. Gently rock from side to side. And close the feet again. And breathe in, come halfway up with a straight back into monkey half lift. And breathe out again down. Again in, halfway up, monkey half lift. And out and down. Breathe in, doing the up diving swan. Bring the arms up. Make have the toes pointing to the outside. Ulnar length space between the heels, or the heels shoulder width wide apart. And go down. Place the elbows against the insides of the knees. Breathe in and straighten up the back. And out, come up again. Bring the arms over the sides down. Again, out, breathe in. And out again, down. Another round, breathe in and come up. One straight line. And out and down. Breathe again in, the arms up. And out and down. Elbows against the inside of the rib cage. Knees, breathe in. And out, the last time up in one straight line. And the arms down. Now we're doing the Markhor. Breathe in, feet are standing together. Breathe out, lean back, draw the shoulder blades together, open the chest to the sky. Breathe in, reach high over, cross the arms, intertwine the fingers. And breathe out, reach in front, hollow the back. Again, in and out. And out and down, draw the shoulder blades together, open chest to the sky. Breathe in, come up, over, cross the arms, intertwine the fingers, reach high. And breathe out, reach in front, hollow the back. Breathe in, come up again. And out and down. Breathe in, arms up, bring the hands to touch and lower the hands down to heart center. That was the power word. I thank you very much and next time.